Thanks,
This conference will now be recorded.
That's the record button. Thanks. So good to be here. I recognise quite a few familiar faces and names, which is good. So just a bit of my background. I actually started on the Western region in 1990, back in BR days with the Reading Area Civil Engineer Office, then went on to the Swindon Design Office, where I bumped into Julia there as well, working on Heathrow Express. Then my career sort of started taking a different path onto London Underground, working with Gibbs and various other people, various overseas work positions and so on. And then back into track renewals with Jarvis and with Balfour Beatty, and then with the sort of later demise of Railtrack. But my career sort of with London Underground sort of re-emerged in 2000, when I was involved with track renewals and project engineering and various assurance activities. So eventually leading up to sort of the role as principal engineer for Points and Crossings. I left there in 2018, worked in New York, for New York City Transit for 18 months, and came back and recently posted as a principal engineer in Technical Authority. So my current work is involved with Intertrack 2, looking at next generation S&C and plain line track, working with our European partners and various academic and universities as part of the UCRIN framework. And my recent role is looking into other materials, sustainable materials, sleepers, and so on. So I'm also involved with product assurance as well. So what are we going to go through today? Hopefully you can see. So just running through the agenda, I'm going to talk about our sustainability strategy, look at the CO2 in track renewals, the rail carbon life models, and also just a quick talk on composite sleepers. So what is our strategy and what's our mission statement? So we want to serve the nation with the greenest and cleanest mass transport. In doing that, we need to look at low emission railways, the improved biodiversity via plants and wildlife, reliable railway service, resilient to climate change, which is a big issue for us at the moment, and then focusing more on the material side in minimal waste and better greener materials. So as part of our Putting Passengers First surveys and initiatives, we asked our passengers what they'd like to see, how they'd like to see Network Rail improve in sustainability and environmental issues. So suggestions of using electric trains to reduce carbon emission, make stations, tracks more resilient to extreme weathers, plant more trees, and High Speed 2 is a good example of that. Where can we plant more trees and how can we offset that carbon emission? And also sending zero waste to landfill. How can we reuse and recycle and repurpose? So a low emission railway. Let's explain how we look at this low emissions and how we're trying to sectorize and scope this type of work. So it's divided actually into 3 scopes. Scope 1 is the actual direct emissions. So these are all sources owned by Network Rail. Any sources owned by train operating companies or freight operating companies are separate to this scope. And in scope 1, we're looking at the actual burning fuels that we use and natural gases we use for heating and petrol and so on, and diesel in our cars. Scope 2 is the actual indirect emissions from electricity for heating and cooling that we buy. And scope 3, which is the largest of our footprint, is the actual indirect emissions for Network Rail within the assets. So it's from supply chains and the infrastructure assets themselves. And a lot of that is the embodied carbon that's introduced right from the start, right from the renewals. And in terms of carbon emissions and CO2 and footprint, you know, it refers to really a collection of different harmful greenhouse gases. So you can see on the top there, you've got your CO2, your methane, nitrogen oxide, hydrofluorocarbons, perfluorocarbons, and your sulfates as well. So it's a mixture of those, but around 70 to 80% of it is around the methanes and the carbon dioxide. And CO2 is a standard unit for collectively measuring these emissions. We normally say CO2e, so it's the equivalent. So looking at these scopes, for scope 1, it's 1% of our footprint, 51,000 tonnes of CO2. Scope 2 is very similar, 2% of our footprint. Now, scope 3, it's 7.8 million tonnes of CO2. So it's 97% of Network Rail's total footprint is within scope 3. So it's a large part of the scope for us to look at and to dissect up. So if we look into scope 3 breakdown, we've got 33% purchased goods and services and capital goods. So that's where our embodied carbon within a lot of our materials lies. Traction diesel, so diesel for our vehicles and diesel for our plant as well that we operate. It doesn't include any traction or electric traction for trains within this scope. As you'll see later as well, most of that is going to come from nuclear sources, so it's seen as zero at the moment, and that's currently how it's been assessed. And right down to waste, logistics and business travel, which isn't happening very much at the moment. Low emission railways. So our ambition is to achieve net zero carbon by 2050. It's 2045 for Scotland. I'm not sure why in Scotland it's 2045, but that's what's been agreed. And it's to deliver continual improvements for air quality to our passengers, neighbours and employees. So looking at that healthier air, what can we do on our roadmap and what are our key milestones for that? So purchasing renewable non-traction electricity, so that's where we're looking at nuclear sources and other sources. Updating our procurement model to reduce value, to actually reduce carbon within our supply chain. And then we're looking at sort of establishing air quality monitoring for work sites and other areas as well, so we can keep a hold on to that. Some of our quick wins, EV charging, so electric vehicle charging for our fleet. Also trials at looking at electrical and rechargeable locomotives as well, and some plant. Hydrogen and battery trains, so we're going to start a trial in 2024 on those. And also looking at some efficiencies within the timetable where we can get carbon efficiencies as well. From a renewable energy purpose, so REGOs, which is the way in which we look at where carbon originates from, because we have to be open about where renewable energy is generated and when it's originated from. So having a sort of clear policy on that. We're also looking at further electrification, so decisions will be made 2029 for where else we can electrify. Traction decarbonisation really is starting, has started already, so we're already looking at those, and air quality management, as we said, for 2024. From a resilient perspective, many of you will notice this, recognise this photo. From a resilience perspective, Network Rail Track and Technical Authority have already started to look at how we can improve our reliability and resilience within the track construction itself. Prior to 2024, we've already started looking at standards, how we can adopt certain reliable targets within our standards, looking at better mapping, looking at conditions or embankments and track and the whole track infrastructure as a system, looking at flooding, looking at buckling, looking better, I think better monitoring on actual temperatures, ambient temperatures, rail temperatures, and forming better trigger levels and more accurate trigger levels where we see a problem may be coming. So we're setting the asset policies for 2024 for standards, and then the long-term climate change projections will continue from there. Reviewing criticality and the vulnerability of our assets in 2024, and then agreeing a level of service in extreme weather conditions with government and regulators by 2027. Some of our quick wins well, we've already started the guidance update 2020. Robert and Poma presented PWI on our how we're going to tackle the resilience in track. So we're mapping high vulnerable areas and prioritising areas where we know weather is a concern and climate is a concern versus the condition of the asset. So that's It's already started that work. By 2024, we hope to have that in place. So having heat maps and various different GIS systems, so that we can actually be aware of real-time monitoring. The route and asset weather and climate change adaptation plans will be implemented by 2024, and policy standards and procedures updated, which is already started. Long-term regional adaptation sort of pathways strategy and the actual investment to these as well will be in place by 2029 as well. So where we're leading with this presentation, really we're looking at the materials and how we can minimise waste and have a more sustainable material within track. Currently our roadmap for minimising waste, we're prioritising materials and waste streams so that we can see which ones are the hotspots, where the carbon hotspots fall, what's our most used and most unrecyclable material. We're then employing a circular economy policy. This needs to feed into our supply chain and also within our standards as well. So it becomes a new way of monitoring and actually ensuring that we do get products that are sustainable for the future. So adapting standards in 2023 and by 2024, we hope to have embedding the materials that are actually within the track. So most of those are being installed by 2024. So we're ramping up to that 2024 date in terms of what materials we want, what we need to approve, what is the best for us in terms of performance, sustainability and function and reliability. And then we'll start to embed the circularity, so we can then start that circle of recycling and repurposing. Some of our quick wins, well, we've already approved some plastic sleepers to be installed. The softwood ban on creosote, which is in place from July 21. That's for our initiative, that's where we have a composite sleeper that can then replace softwood and hardwood and later steel and concrete for when we approve it for higher category tracks. Reducing waste, zero waste for landfill 2024, that's the target. How are we going to get there? Can we look at certain products and materials within track renewals and track operations that we can help to reduce that landfill? Adopt circular economy principles, as I stated before, working with supply chains and reuse for 2029 to redeploy. So it's the circular economy where we need to start reusing, producing materials that are designed to be used within a circular economy rather than an end life where its final destination is unknown. In doing this, we need to maintain the momentum, otherwise we come to certain gates and we just don't have that flow. So we need to make sure in looking ahead and looking at the detail month by month where we'll be. So currently, June 21, you see circled down the bottom there, bottom right. So we're looking at employing green champions, putting them in place so that those champions can look in certain asset areas to see where we can make those improvements. And that's where we're starting to develop a baseline for the whole life carbon in assets established. Currently, we've got an idea of carbon that is used in the capital expenditure for renewals, but for whole life, we're still finding our way, and I'll go through that shortly. So, track assets, track renewals. Most of you understand a track renewal and what's involved with it, the type of materials that's included. Now, for projects to help projects see how much carbon is being used in a renewal, RSSB and Atkins produced the rail carbon tool. So this is an online tool. It's used to calculate and analyse the carbon footprint for UK rail projects and activities. So it's not just Network Rail using this, it's other infrastructure companies using this as well. It is a UK-based tool. Similar ones are available in Europe, but most of those are provided by suppliers or other third-party platform providers. So it enables you to select the low carbon solutions and materials. So you have drop-down menus to show which type of materials have a lower carbon, which type of plant, which type of activities, and so on. It identifies and assesses alternative options you can do the carbon footprint calculation, and also you can analyze the results from carbon models and different projects, so you can compare between the two. So for us, this is a great model. It only looks at the snapshot when installed. You see on this example here, we've got sleepers, G44, pads, fastening, ballast, welded rail, membrane. So it goes down to that level. We've divided that down. We've done a bit of analysis. This is based on a typical 440 yard, 27-hour renewal, 400 meters. So 5% of the CO2 is within the ballast. 24% is within the concrete sleeper, so that's one of our top three. And then going down the list, there's small percentages of fastenings and clips, but they're not to be ignored. Locomotives, I think that's our third highest. And then going down to the welded rail, which is 41%. So that's supply of the rail to site, the install of the site, the embodied rail. And with that comes the welding as well. So within the rail, you've got the welding and you've got the stressing that's involved with it. Again, only just for the installation, not for its whole life. So what does that mean in terms of, well, what is it in context? How do we contextualize this? So a track renewal has, for 400 meters, has 207,000 kilograms of CO2. That's 103,000 trees. From the rail perspective, that's 204,000 miles driven in an average car. Concrete sleepers, 10 homes of electricity demand for a year, and for locomotives, over 4 million smartphones charged. So that just gives you an idea of how much carbon we're using in relation to what we do most of the days. And this is the track system we're looking at. So we're not looking outside of the track bed. We're not looking at drainage. We're not looking at earthworks. Not looking at any civils assets. It's just the track at the moment. You know, we can step back from this and start to develop tools for drainage, for embankments, for earthworks, and for all of the other structures, so we get a better whole system perspective of what we're doing. So how can we drive those down? These are the top three, and 80% of that carbon used in track construction, track renewal, is down to these three. So rail, how can we use longer lasting wear resistant grades? How can we employ those and use those in areas where they're needed, where we get high rates of wear? And we can then reduce CO2 by 50 to 80%, you know, dependent on where they're positioned, their life extension. Just by life extension by 3 or 4 times, then in a whole life carbon assessment, then you're going to have a reduction. Manufacturer using electric arc furnace, so there's a reduction to be had there. Once again, that technology is used more commonly. Currently it's not, but it can be deployed. It's a case of when do we need it and is it actually required for the future? And I think the answer to that is yes, it is needed, and we need to start bringing that into use now. We can monitor wear more precisely, so we can actually gain full usage of the rail rather than a sort of early or premature taking out service. And then improving scrapping initiatives as well. We do recycle a lot of rail, but how can we do it better? How can we do it more efficiently? So 24% of that rate is also within concrete sleepers. That's your standard G44 concrete sleeper. So by using composite recyclable materials, we can reduce CO2 by half, and by using something that's also recyclable. Currently, concrete can be recycled, but it's very difficult. It's extracting the tendons and the stressing wires and all the other parts. So it tends to get crushed and used as backfill. So it's not repurposed into what we could say, you know, its original material, i.e. another sleeper. USP, so under sleeper pads, we know that they increase life. They reduce ballast and track system degradation, overall degradation. So by increasing the life, we decrease the amount of carbon over the life cycle. And by using eco-friendly mixes, so substitutes for cement, PFA, sulfur, so they can reduce CO2 by 20, or even as shown in the new green sleeper, up to 40% reduction. On the locomotive side, I think still more work is to be done there, looking at sort of battery powered and electric rechargeable locos. there's discussions about trials for recharging from overhead lines for battery powered locos. And there are ways of actually improving installation efficiencies using less locos, less idling, and so on. So as we bring in efficiencies with plant, we can also reduce the use of other plant elsewhere. So let's just go into the rail and the sleepers. So just looking at the rail initially, this is a wear model that was generated by voestalpine, just to demonstrate, you know, how rail over its life wears and the sort of cycles of grinding. So you've got the top left where you've got RCF developing just after its first installation. We then start the downward steps are the grinding and milling activities going in there. The natural wear is the downward slope. And at some point we're going to reach that wear limit. So that's the end of life, where we then need to 20 years, if you see down here on the bottom table there, 20 years we're going to need to then replace that rail. There's also the concerns over the actual superstructure, which is the track, how the track is also performing and the life of the track, because in some cases the life of the track is twice that of the rail. And then there's also the fatigue limits, isn't it, as well, we need to look at. So when you look at the actual life cycle of rail, and dependent on the rail grade and the radius and the annual load, so those are sort of the parameters we need to look at to assess this. You could then start to look at how much carbon is actually used. So working within Intertrack 2, this was presented by voestalpine. This is their life cycle cost model. It's life cycle cost and life cycle carbon. They're able to map, in this example here, they've mapped a section in southern Austria, which shows the carbon hotspots. So you'll see some small little red sections there, and yellow, orange. So they're, as you can see, they're the tighter radiuses where we're going to need to changing those rails more often. So more rail changes equals more carbon. So they've looked at the length, the radius, and this is using 260 rail. And this is the carbon model for that whole line as it stands at the moment, just in terms of rail, not the superstructure, not the sleepers, just the rail. So by then looking at certain areas where they can use higher grade steels, such as R400HT, they can then look at what savings they have. So currently the emissions are 0.094 tons per metre CO2 over that 868 metre length. Going on to the next slide, so this is using the R400HT, where that figure has dropped down to 0.0118. So it's dropped down from 9 to 2, basically. Now you can see the reds have gone, the greens have appeared. So using it on those certain sections that have the red and the amber sections, which is probably only about 15 or probably less than 10% of their infrastructure has got those curves in there. But by using a higher grade steel, they've dropped the carbon. Here's the table that just goes through some of that data. So that's the viaduct, that's the area where it was actually installed. So 25 million gross tons, length 868 meters and radius 172. It's 760 rail. So with R260 standard grade, they're predicting a life cycle of 3.4 years. With 400 HT, they're predicting 18 years. So that's a 529% improvement in life. The cost savings from 66 euros per metre down to 16 euros per metre, and CO2 rates go from 94 down to 18, so that's an 81% reduction. And that's by just deploying the higher grade steel and the extended life. Now, the steel itself doesn't actually use more carbon to manufacture. If it is, it's very, very small and insignificant in terms of these figures. It's more about life extension. So looking at where we are with steel production currently and where we hope to be in the future, this graph shows us in 2019, so it's a year old, this data, and where we hope to be in 2050. So this is steel production global. This isn't just rail steel, this is steel for construction and all uses. You can see that in Europe and the European Union, we currently have around 55–60% blast furnace use, small, around 40% scrap, and a very small section there on electric arc furnace, but not much on other ways. The improvements are going to be more recyclability, and you can see the introduction of electric arc furnace providing around 10% of that as well. So this is just a forecast. Just hopefully that will give us some reduction in steel production, which we can then see in rail. So if we start to look at lower carbon in rail, higher usage, better premium steels, better understanding on wear and wear modelling, then we should be able to reduce that CO2 further. Sleepers. Okay, so I don't know if any of you guys saw last week on the news, there was a new green sleeper introduced in Belgium. So this has 40% less CO2 than a regular sleeper and uses sulfur in place of cement, and it's fully recyclable, so it can go back into the reuse system as well. So this is on trial in Belgium, so I don't think it has gained full acceptance yet, but it's something for us to look out for in the future. We need to understand the costs and performance and so on, but it's certainly a step in the right direction. Network rails, I guess actions and where we're going with this. This is the composite sleeper. They've been produced for around 15–20 years. They've been produced. We've had them in the UK, I think, since around 2015 or 14. First installed on London Underground as sleepers and SSE bearers. Soon to be installed on DLR and now installed on King's Cross. So first installation for Network Rail happened in March. It's being handed back, I believe, in April. And this particular use for King's Cross Gasworks Tunnel, issues there were that using hardwood, we'd need to chamfer the end and shorten the end due to the tunnel invert. So by using the plastic, we can guarantee a better performance from that, as well as all the other improvements from CO2 and sustainability and so on. So it's approved under trial. We're then looking at approving for higher category tracks. So this is sort of up to category 3 at the moment. But for higher category tracks for 2 and above, and replacements for concrete and steel sleepers, that's our next step within technical authority. So if we were to use composite sleepers, this is just a projected saving in CO2 over the next 40 years. So if we say 2025, we'll start to see those sleepers going in. What will we see over the next 35 years? And that reduction in CO2, we're looking at around 50 to 800,000. 50,000 tonnes saving, so it's quite a large amount by deploying composite sleepers. That's based on, we currently use 700,000 sleepers a year, somewhere around that 600 to 700,000 in Network Rail. So this slide came about recently. I was on site on last Tuesday. We were trialling some new concrete sleeper. We're trialing the lifting equipment for the new profile concrete sleeper, and one of the guys there from Colas suggested, why don't we actually recycle the plastic products? Why don't we recycle insulators, clips, pads, nylons, all those other things that we tend to throw away, throw in the ballast and get forgotten. So I thought this is definitely worth looking into. How much does it cost us every year, and what are the savings? So you've 2,100 tonnes per year on the rail pads, and 1,800 tonnes per year on rail insulators, and 8,200 on rail clips for the steel. So there's quite a lot of carbon there that we're wasting and throwing away. And most of the time you throw it back in the ballast, it gets dug up and it gets scrapped somewhere, but it's not getting that reuse. So it's worth considering that. So now going on to some of the work we did with DLR and the TfL, looking at sustainability and environmental impacts. We did a quick study with the supplier on hardwood sleepers versus concrete sleepers and Syca, the composite sleepers. For Beckton Depot, they were looking for a sleeper alternative, something that the cost wasn't too large, or the cost difference, should I say, but also looking at sustainability in the sense of how long it can stay in there for, what the expected life will be, and also embodied CO2. So we did some calculations on the embodied CO2 and showed a 77% reduction in use of Syca composite sleepers versus hardwood sleepers. The concrete sleeper itself it's for £80 rail and was available, and you can see the CO2 emissions 70.6 compared to 43.3. Now hardwood does have a lot of CO2 involved in its manufacture and embodied, so it's quite high. It's 4 times as high as a composite sleeper. In doing a lot of this work, we've realised that to do a correct and accurate assessment, we need to have a life cycle assessment tool done. And I think the increased awareness of environmental protection and making sure that we are building for the future has caused us to need a life cycle assessment tool. So that will really help us to identify the opportunities to improve environmental performance of the products, and then also inform the decisions. And that's within the industry also, and within government, within organisations, within suppliers. So anyone involved within that chain should be involved with this and has a part to play. We can then select the relevant materials, and then we can also have a way of measuring it as well, so validating. Also in terms of marketing, so implementing an eco-labelling scheme, so you can actually say that if your product is more eco-friendly than another product, what's the metric for that, and how can we have a sort of comparative sort of metric? And if they're making an environmental claim, are we all making an environmental claim on the same basis, using the same data and the same sort of baseline? So for Network Rail, we decided to look at, within a track whole life or a life cycle assessment, what those activities involve within plain line track. So this is for plain line track, not for SSC. So we broke down the activities of tamping, grinding, milling, re-railing, re-padding, re-keying, re-sleepering. Some remediation works for wet beds, and re-sleepering is only needed where you need to re-sleep in some sections. It's a small activity in most plain line track sections. Ballast cleaning, either as a life extension, because it could be just the ballast in the end that is the actual factor in the residual life that needs to be replaced. And then to rail defects, re-stressing, inspection, basic visual inspection. You wouldn't think it's a great amount of CO2, but we do have guys walking out there doing lots of inspections currently at the moment, manually and visually, which, using vehicles and using the whole fleet, that does start to add up. And then there's the TRV and lubrication and so on. So what is its usage? What effect does it have? And how can we actually accurately determine the cycles of those activities within the life cycle? So, for example, grinding, how many times do we actually grind rail in its life cycle? We currently base it on tonnage. We do have some real life models that we use. Some of it is a strategic decision because it's simpler to do it that way. But with better, I think, rail life modelling and degradation modelling, we could come up with more accurate ways of actually determining when that should be done. So if we can use those activity, the current activities frequencies, and we know the CO2 for each one of these activities, we can then start to develop our life cycle cost model, so our life cycle carbon model. And then what's included within that activity in terms of the machine, the person, disposables, small parts and travel to and from site and so on. So what's actually involved? And it could be in terms of shifts, because in some cases it could be 3 or 4 shifts of a tamper or a grinder or a ballast cleaner, or so it's looking at that. So we've done a very basic carbon model. This is still to be validated, and it's using figures from the RSSB tool. So top of this, just to explain, this is 1 kilometre of CWR on Cat 1 track. The rates are based on the 400 metre 27-hour renewal data that we have, and this is for a 30 years service life without USP. So that's our standard sort of baseline at the moment. So the amount of tamping, so we've got the frequencies for tamping, we've got frequencies for rail grinding, rail replacement, sleeper replacement, which may just be a token number really, just to show some figures there, but can be adjusted depending on area and underlying conditions. Ballast cleaning. So if we wanted to extend this for another 10 years and decided to ballast clean maybe at 20 or 25, then we can sort of develop that into the model as well. Restressing frequencies, repadding, reclipping, inspection allowance, and sort of spot replacement as well. So we've got the CO2 amounts there, we've got the whole life totals, and then we can look at how many kilograms per metre per year we're actually consuming on CO2. And that's our figure there, and that's what it currently looks like for our standard 1 kilometre of Cat 1 track. So we look into the future and then we say, okay, what can we do? We can increase from 30 to 50 because we're getting better products now. We can have sleepers that last longer, track systems, we can maintain it better. We've got better degradation tools. Some of the things such as tamping, we may be able to reduce tamping. Certainly with under sleeper pads, we know we can reduce tamping, and certain materials, tamping frequency is less. But in terms of the initial carbon from the track renewal, so that's where the embodied carbon from materials lies, the rail, the sleeper, and the locomotives as well, and all of the plant used. So we can reduce that, and we've done, I think, a reduction there of around 20%, but we know we can go better than 20%. This is just an indicative figure at the moment, just to see where we can get to, and so we can start to plan goals, plan where we need to be. So we have a glide path to get there and where we need to be. So this could be 5 years time, where we have 20% reduction in CO2, but we also have an increase in asset life and a decrease in some of those activities. So if you look down the bottom left, this is what it includes: so composite sleepers, low CO2 steel, longer life, extended life of the overall track system, autonomous inspections, a saving on the BVI, battery locos as well. So that brings us down to 16.1. So that's gone down from 32 to 16.1. So we reduced it by half. Again, this is just used as a tool just to see where we need to improve. We need to validate it. We need to get more accurate figures for rail grinding. Tamping, we're pretty much, I think we've validated those figures for tamping, but for rail grinding and for other things, we need to sort of validate those figures more accurately. But it's a start, and this is then the plan for Network Rail is to use this and to also adapt the RSSB carbon tool to include whole life carbon for the future. In terms of those improvements between a 30-year and 50-year life, so you can see there the renewal for 30 years in blue dropping down to, and this is CO2 per year, kilograms per year. So we're not the overall, this is per year. So you can see where most of those improvements come from: rail exchange, the actual track renewal, inspections dropping down quite heavily as well. So again, it just shows you where your big wins are. So deciding what type of material to use for our sleepers, there's lots of literature available and information. This particular one is referenced from Intertrack 2. It's supplied by Newcastle University for composite sleepers. And and they did some research into the waste and recyclability, the emissions and the pollutants for each of those sleeper types. So they developed this graph, or this table, to show the dark green being the greener, and as you get to red being the worst. So you can see with soft woods, which will soon be removed from this table because we won't be using them, but they're still in the track. And for some reason, concrete is blacked out. I'm not sure why. That's probably because that's the baseline of where the worst conditions lie at the moment. But you can see a steel comparison there. So steel is relatively recyclable, so it still gets the green, and it can be recycled back into steel sleepers. The problem is it does use a lot of gas emissions, and in terms of pollutants and hazardous waste and so on, it's yellow rather than sort of light green. So most of the ones that do tend to scoring highly are the sort of synthetic HDPE type composites, so it's your recycled plastic type ones. And then you have the FFU, the Sekisui type as well, which is fiber, that's the sort of urethane type filled foam, which has, as you can see, very similar attributes to HDPE and composites, apart from on the sort of high traffic usage and the sort of the actual CO2 there. So that's the way of looking at it across all of these sort of sustainable sort of metrics, not just looking at CO2. Now, in terms of having a material that we can repurpose, how does that help us? Well, repurposing, certainly repurposing into a life where it can be actually buried in the ground for 60 years and being used, buried meaning, you know, a sleeper, and being used for 60 to 70 years and then being repurposed. For us, that's a circular economy plus. That's actually a higher level than what we currently do. At the moment, our circular economy involves plastic bottles that go round in a circle, and you're probably talking about every 6 to 8 or 9 months, that bowl comes back around again. It gets used, it gets recycled, it gets repurposed and sent around. Eventually, the material itself degrades because you don't have the actual material strength to produce what's required. But whereas with some products, the recyclability is direct and it can last 3, 4, 5, 6, 7, 8 times more, especially if it's being used for sort of 50 to 70 years as well. So you can see that could be repurposed and reused for 300 to 400 years, whereas plastic bottles probably have a shelf life of 2 or 3 years. And in terms of saving of hardwood, 2.5 acres make up a mile of track. Average hardwood is 15 to 20 years in track life. Most of those now probably 10. We're getting a lot greener. They should be grown to 100-year life, but we're chopping them down a lot greener now. And in terms of plastic, so 1 mile of sleepers equals 170 tons of waste removed from the environment. So it's out of the oceans, locked away for 50 years. So concrete. Concrete is, well, the statement at the bottom there is nearly 8% of the world's greenhouse gases is caused by OPC cement. And if concrete was a country, it would be the 3rd largest in the world. It's the other statement that cement has transformed the world, but now threatens to wreck the environment. So I think concrete still has a part to play within our construction. We've seen the green concrete sleepers. We've been speaking to our concrete manufacturers, and they have ways of reducing CO2. So it's not the end for concrete. We know as an industry across the world, globally it is an issue. But for sleeper manufacturing, there are ways around it. So I think it's more a case of having to make the suppliers adopt into our, this awareness of greener materials, and that products for the future need to include that. There is an EN standard on environmental management, so it's a EN and ISO standard 14040, and this is where the life cycle for carbon emissions exists. So it takes you through from product all the way back round to end of life. So it looks at each one of those areas, and it provides a standard approach for calculating CO2, calculating emissions within the life cycle, for recyclability, for repurposing, reuse. So by following that standard, everyone can then use the same approach and same methodology for calculating it. And just to provide some sort of comparison between other materials as well over that lifespan. So ringwork that's a timber. So they're actually showing for timber that it's a type of timber used in, I think it's used in Sweden, and 2 and 3 they're concrete sleepers. PAV is a recycled plastic, and Lankhorst is another supplier for recycled plastics, but they do use a steel reinforced rodding in there, so there is some quite high, although there's reuse of plastic, which is good, that the steel rodding does include some CO2. And then psych up there. So that's the comparison really of CO2 per sleeper per year between those 6. And these assume all products have the same service life as well, and I think that's just predicted on 20 years. So it's treated softwood sleeper was predicted for 20 years for the first one, so they just took 20 years, but they've also validated this for 35 and 50-year life as well. So on my closing thoughts, what do we need to do next? Us as an organisation, as an institution, and various people within those organisations, how can we all improve these things? So I think we need to improve sustainability awareness, certainly within track materials, operations, whole life. So that's within the designers, with those that specify materials, with those end users. A lot of it is based on whole life cost rather than other issues, and I think cost comes into it quite a lot. And if it's initial unit rate cost versus whole life cost, then at those stages it becomes difficult for people to adapt and use more expensive materials. So we need to do better whole life costing and whole life carbon assessments as well. We need to improve specifications for sustainability. So current specifications for materials, for sleepers, for rail and so on, we'll talk about performance versus duty. The sustainability is starting to be included, certainly within Network Rail standards. We refer out to design for reliability. And within the design for reliability section, we've got a part on sustainability. So there are some scoring mechanisms there where we can actually score new products against each other in terms of sustainability. What cost is carbon reduction? A lot of people are saying, how much cost am I going to need to or invest within this to reduce carbon? And the answer is we don't know. Certain people look at the cost of materials at a unit rate and say, why am I paying more for it? Because it's got less carbon. But we've got to also think about the planet. And we have most of these where we reduce carbon and we increase life cycle, we also decrease the whole life cost as well. So if it's whole life cost based, both models are very similar. You could have a whole life cost model and a whole life carbon model, and all you need to do is take away the CO2 part and put a cost in there. So they're both similar models. Develop better recycling initiatives for sites and materials. So certainly within renewals and within maintenance as well, how we can collect up used materials and recycle those. There's already a lot of initiatives in place. The question is, have we got any more we can use? Have we got any other ways of saving and recycling? Validating carbon tools to ensure accuracy of data. That's where we need to go next. We've got carbon tools that are still in their infancy and are good indicative tools for us to see where we need to lead our research, but we need to have better, more accurate data to be inputted. Strategize track in line with the NR Zero Carbon 2050 initiative. So our track initiative needs to be in line with that. We need to be reaching those same targets. So a nudge or a poke to the suppliers to say, start thinking greener. We're all thinking greener ourselves at homes with our vehicles. How can we do it within the track infrastructure itself, and how can suppliers help us doing it? And to be fair, a lot of suppliers are, but there needs to be, I think, a strategy or something that comes down from high and above to say, this is what we now need. We're not looking at it from this angle, we're not looking at it from the green angle. And I think that will come over time, and people are starting to sway over in that direction. And really, what other UK rail infrastructures can follow suit? Who else within the UK can do similar things within other infrastructures? I'll be interested to know what TfL are doing, what Transport for Wales will be doing, and any other areas within light rail networks to see if there's a shared UK. And there are bodies and working groups for UK rail carbon that look into this, and if we've all got that same shared goal and the same metrics, then it's going to be, I think, a lot easier. So that was it. That's my presentation. If you have any questions, please fire away now. Anything I can't answer now, because if it's deeply on the sustainability level, I can always contact my some of my colleagues within the Network Rail sustainability team. But yeah, so the floor is open to you guys.
Thank you very much, Darren. So just a reminder, if you've got any questions, please put your name into the chat, and I will ask you to come and ask your question live to Darren. So while we're waiting for people to pose their questions, one of the last points you raised, Darren, was about the whole life cost. Again, the whole life carbon. Now, the whole life cost is something that's been talked about in Network Rail for quite a while, and we never had a good way of doing it. And if we had, I don't think it is really applied. So that comes alongside the new cost challenge that we've got with all the money that the government's got to put into the railway, I think to the like of £10 billion over the last year or so. Mm-hmm. So what sort of investments, are we looking to have at the start to kick off this whole like carbon reduction?
So the initial investments is a dedicated team to look at it. So by producing a team that actually their sole purpose is to reduce carbon, and then to spread the word, look at how each area can improve, look at the problems and find solutions for that. So that's one of their, one of the initiatives, and in some cases they're treating it as business as usual. So within technical authority, I'm sort of the person that's dealing with the the materials within track and other things, and it's being treated as part of our everyday work, really. So they're reaching out to various people within the organisation, within different disciplines, to see where we can get those, and that was the member of the green hats that come together and look at all of this individually. Now, in terms of investments into how we can improve things, so it's all about trials. So certainly with the electric vehicle charging trials, the locomotive charging trials, is finding money so that we can do the R&D for that. So there's the investment required to do the research, to then for those to become approved and to be used to ensure that they can actually be rolled out into use. Then what comes next, really, within the supply chain and within the route services, is their concern would be: are we increasing the cost of track renewals by a concrete sleeper changing from, say £80 up to £105? The answer is yes, we're increasing the cost because we've increased the sleeper cost by £20. So for route services, that would be a problem because their role is they've got capital investment expenditure, which they need to spend, and it doesn't really consider how that whole life cost is extended by doing that. So the business needs to then say, right, we recognise this. We recognise in the future we'll be doing less renewals because we've got a higher performing product that's more reliable. So therefore, your budget will start to be reduced. And then it's looking at that long-term spend versus the gain that we get. So we're going to have to do those projections. And there's going to be, I think, an initial investment cost in this. So if you think of an initial capital cost being increased and then over the years decreases, where's that money going to come from? How are we going to source that money? How's it going to be actually implemented within the sort of the route services and track renewals organisation? So that's quite a headache, and that's just track. You know, there's other things like there's the investment for increasing the electrification of some of the lines for efficiencies. There's also modernising fleet to make them more greener. So there are some investments where they line up with the current end of life. So if it's end of life and whilst we're replacing it, can't we make it greener as well at the same time? But what we tend to do with track is just put in the same old stuff. We get sleeper for G44 for G44. We should be actually step by step, you know, making those improvements, better rail, better clips, better sleepers. And yes, with that will come a cost, but we won't be doing it as often. And that's where we need to get that investment.
Yeah, and I think that's the sort of dilemma we've got at the moment, isn't it? Is the cash availability versus investment for the longer term.
Yeah.
Okay,
Yep.
Thank you, Darren. I'm going to move on. Paul, but you had a question regarding composite.
Yeah, hi Darren, thanks very much.
Hi, Paul.
That's really good. Just you mentioned in there something called hybrid composite. Excuse my ignorance. Just what's that?
Did I didn't mention the word hybrid, but hybrid is sometimes used. So composites do form very many different forms. So in terms of a composite plastic recyclable sleeper, and that's what we call it, you know, the composite used within that is high density polyethylene recycled, and there's also some other fibers in there as well. So the high density polyethylene is a recycled material that's used. It comes in sort of granular form. So when we talk about composites, we talk about a mixture of it could be a virgin material, a recyclable material, a filler, an agent. So we know we add UV agents to things as well because a UV agent stabilizes it against UV. So it's producing this whole composition of materials, and into that could be, I would say, a composite could also be a steel reinforced plastic sleeper. So there's steel reinforcing going through there, and then you've got plastic surrounding it. So again, it's another form of a composite, and it is like a hybrid in that sense because you're mixing steel with plastic. I know we mix steel with concrete, but we call that reinforced concrete. You know, so it's got a name, but no one's got a name for reinforced plastic. So they tend to put it in that sort of hybrid stroke composite, you know, pigeonhole. And we do suffer from this because we talk about composite sleepers sometimes, and we have to say which one are you talking about because they've got so many different characteristics. So you know, you look at the sort of failure characteristics between, say, an FFU type Sekisui versus a composite, which is a recycled plastic. Then some of them have a tendency to delaminate, to crack, to splinter. Some have a tendency to bend. Some have a tendency to creep, so we have to look at the creep in the material, how much it creeps and deforms, where's its elastic limit, and where are we going to get into a sort of a permanent deformation of a sleeper, you know, so we need to understand that. Whereas with concrete, it's pretty straightforward. We know when it goes, it doesn't tend to bend. So yeah, has that answered your question, Paul?
Well, yeah, that was really interesting. I know there's articles around about composites, so thanks very much. Another talk I see ahead.
So Manny, what's your advice on CRE track designers on their role to support on carbon reduction initiatives? Should carbon reduction initiatives including, I think so, in DRAs? I think they should. design risk assessments really do just look at those hazards and those risks at the moment, don't they? I know I've been on plenty of design review panels and IDRs and so on where there's a sustainability or environmental comes on, and it's about the environmental aspects of the track or the renewal, or is there an ecological concern, is there a concern over something else? And I was thinking about this, some of the jobs where we put a lot of steel sleepers in, and we then have to put, certainly on some track where if you've got steel sleepers in CWR, which isn't on tight curves, which isn't really allowed, but in some cases it still exists, and you have to put the extra strength in rails in this. It's more rail to manage, more rail to install, more carbon, and you sort of think to yourself, okay, there's better ways of doing this, and if designers are aware of something that actually, as a designer, I could, suggest or specify this, because once it's on a drawing, it's then started the conversation. It's what you call the nudge, and that's what I spoke about earlier. When you've put something onto a piece of paper, or you put something into a meeting, and you've got then people talking about it and considering it, it's better than actually not mentioning it at all. It may be completely put down and said, no, we're not going down that line, but we need to have sort of sustainability strategies to say, actually, from now on, we're not putting any more steel sleepers in, it's going to be plastic. And then eventually we'll have a new sleeper to replace the G44 that's more economic, more eco-friendly, and it's making designers aware that actually we should be putting these new products in now. So it's the same argument as under sleeper pads. Most designers would love to put them in because they know all of the improvements they provide. But when it comes down to capital cost, it's like, no, sorry, can't do that. Or is it really required for this site? Are we over designing it? Are we over engineering it? It performs well at the moment. Why can't it perform with the same materials going in? And in most cases, we've got to make things more resilient because we've got temperatures are changing, climate's changing, capacity is increasing in a lot of our lines. And we know capacity is going to increase by about another 15-20% over the next 20 years. So what are we going to do about that in terms of track performance? We need to build that in now. And that's where the cost comes, So hopefully that's answered that one. Rob Howell, hi Rob. Is traction being, so yeah, traction isn't within my track section, but it is being dealt with. If it's electricity traction, what we tend to look at is the fact is that by 2024, all of that's going to be nuclear generated. So currently they're giving it a 0, but electrical sort of third rail systems or Southern Railway, that's a different side, because that actually is borne by the TOCs, so the train operating companies need that to operate their service. We don't manage that section. So that anything to do with stations, so train operating company stations that generate CO2, that's within their own carbon footprint, and so is the traction for their trains and anything their train needs. But what we are doing from an electrification point of view, we're bringing that in-house because we recognise it's going to be nuclear in the future. We start to be now, but it's going to be nuclear, and then it's then going to, the overall improvement is going to be there for everyone to share. Hopefully that's answered your question, but I'm not dealing with traction. Matthew, is there much in the way of international benchmarking at the moment? There is, and it is CO2E, and there is the ISO standard, but benchmarking in terms of life cycle assessment, we speak to very many people that have different ways of calculating carbon, and some cases they've got carbon credits, some cases they actually feed into the loop the recyclability and repurposing of materials, so it does become 0, and everyone's got their own way of showing data to obviously show that they've got a good material in use. So we have to be mindful of the fact that we do need that common data set. So I think the EN standard has helped, and environmental initiatives and directives and environmental directive statements for each projects are being developed so that project by project they can say this is how we're going to help the environment. And in those areas where they're really struggling to show an improvement, that's where they need to start looking at sort of the materials they're using. and then we need to make people aware of what the savings actually are. So if you're looking for a 50% reduction in track CO2 over the next 50 years, this is where you need to be to meet those targets. Are the composite sleepers approved for use in the subsurface locations for fire performance? Yes, they are. Network Rail's fire performance standard is different to TfL's. There is a standard that specifies flammability, toxicity, ignitability, but there isn't anything about smoke density. Smoke density is a LU specific specification for fire performance, but it's approved. It's in Gasworks tunnel, and the requirements for that are within our standards. So on the composite standards, just to let you people know, we're currently writing a standard that includes bearers, sleepers, and long timber bearer systems as well, wheel bridge bearer systems. So it's all going to be combined in one standard. So no TfL have one similar, and we've got a technical specification for composite sleepers at the moment within Network Rail, and we're building on that. And then the next steps for us are to go out to tender for S&C composite bearers. That's later on in the year. And also for full product acceptance for composite sleepers, sometime towards the end of this year, early next year. Well, I think early next year will be for that, once we've had a full season of trials. So I think that's it. We're almost running out of time, aren't we?
Yes, we are, Darren. So we're going to try to finish in a couple of minutes now. Thank you very much for coming, Darren, and to do this amazing talk. I certainly learned a lot about what we're looking at to decarbonize the railway. I think, like a lot of engineers, still trying to find out what our role is at local level, how we can influence the carbon reduction. It's a topic I'm particularly passionate about because of, I guess, because of my children, wanted to leave a legacy, a sustainable legacy to them, and also because as engineers, you know, we sign off to the professional code of conduct, and this is one of the elements in the code of conduct. So having you today to actually enlighten us on what it means, you know, get us to think about what we can do as engineers, I think for me was very, very important. So yes. I think on behalf of everybody, Darren, thank you very much again for coming. And I wish everybody on the call a good rest of the day. So closing the meeting now. Thank you.
Brilliant. Thanks, everyone.